Good morning, everyone, and good morning to you, sir. Today, we will be discussing about the medieval period in history of mathematics, with the context involves the development of mathematics during the medieval period, mathematicians in medieval period, and also the achievements that were developed during or within the medieval period time or medieval era. Also involved are the famous mathematicians and their contributions of mathematics in the medieval period. To start off, so we have here the mathematicians during the medieval period. So some of these names are not profoundly known to the world, to the entire world, but these are the mathematicians during the medieval period. So such as Aryabhata, we also have Al-Khwarizmi, Bhaskara, Al-Kazini, Al-Samawal. So, yan sila yung mga mathematicians. We also have Brahmagupta, an Indian mathematician. So, tip lang po na si Brahmagupta. So, tinagurian po si Brahmagupta na isa famous mathematician during the medieval period. So isa siya sa maging inspirasyon ni Isaac Newton and ni Gottfried Leibniz sa paggawa or sa pagdevelop ng calculus. So ayun po, so these mathematicians helped develop math during the medieval period or the Middle Ages. So they help develop and achieve one of the greatest achievement that is well known in the field of mathematics. Now let's move on to the medieval mathematics. So there is much fascinating material to be explored in the history of medieval and early modern mathematics. But perhaps the first thing to be aware of is that particularly for the earlier centuries, almost all original sources are in Latin. Meaning, lahat ho ng naging sources ng mathematics ay sa inscribed siya sa Latin words. So, mathematical Latin uses a specialized but relatively limited vocabulary. And if you know some Latin already, you can build on it. But if you have none, you will need to devote time learning it. So, the medieval period was a period of gradual mathematic development. In other ways, it was a period of great philosophical shifts. Not so much on the surface, as the Roman Church dominated much of philosophy and all of religion, but underneath. The old Aristotelian views began to erode, though it would dominate education for many more centuries. Certain notions began to be admitted. Most particularly, we see a lively discussion of the infinite, actual, and potential in mathematics. Now, medieval mathematics was, on the whole, far removed from anything that we think of as mathematics today. Indeed, to study this period, at all you need to be prepared to enter a world whose preconceptions, political, religious, or mathematical, were very different from our own. Meaning, ito kasing medieval mathematics na ito siya. It all came from the Middle Ages pa. Meaning, iba rin talaga yung na-develop nila doon at sa ginagamit natin ngayon. But, we also have similarities na nagiging matatin. Kumbaga, mas na-develop lang yung mathematics natin ngayon. We say na parang iba na yung mathematics natin ngayon, but similarly, we always stick to the original pa rin naman talaga. So, there are texts that are recognizably devoted to arithmetic, geometry, or occasionally algebra, but most of the writings that were later described as mathematical were concerned with astrology and astronomy. So, and even theology. Kasi nga po, the distinction between the two was often blurred, and other borders on philosophy and natural philosophy or early science were also devoted sa medieval mathematics during Middle Ages. So, mathematics during the medieval period. So, Indian mathematicians developed some of the most important concepts in mathematics, including place value numeration and zero. By developing new techniques in arithmetic, algebra, and trigonometry, medieval Indian mathematicians helped make modern science and technology possible. Their innovations were brought to the West when treatises by Muslim scholars were translated into Latin. So during the medieval period, ang nag-carry ng mathematics during the medieval period was the Indian mathematician. So pasok na po dito si Brahmagupta, which was tinaguri ang most famous medieval mathematician. So why was math important in medieval period? So the interest in mathematics in medieval Europe was different from that of contemporary mathematicians. They held that mathematics provided the foundation for comprehending the created order of nature, and that this belief was supported by both a scriptural scripture for the Book of Wisdom and Plato's Timaeus, which gives an intricately crafted narrative of the universe formation. So meaning that in everything that has been developed throughout the years, throughout centuries, mathematics has always been the foundation of everything. From buildings to sculptures to paintings to music, lahat yan may kaakibat niyan yung what do you call that? Ang mathematics na ginagamit natin up until now. So from architecture to engineering, ayan, ginagamit yan. Even the Egyptian times, in Babylonian times, it has always been mathematics has always been very helpful. Now let's move on to the famous works in mathematics in medieval period. So first we have the Quadrivium, or the core curriculum in mathematics. So typically included arithmetic from texts like the Boethius adaptation of Nicomachus, Introduction to Arithmetic, or a medieval text on calculation rules. We also have geometry from Euclid and one of the practical geometries. We also have music from another Boethius work, and astronomy from Ptolemy Almagest, and more Latin translation of Islamic astronomical works. So the quadrivium has 4 aspects: the arithmetic, geometry, music, and astronomy. So let's start first with the arithmetic, or the number in itself. So as such, number is a pure abstraction outside of the time and space. This aspect of the quadrivium deals with the different characteristic of each number. So arithmetic talks about the number itself already. So meaning outside of the time and space, ito siya. So it deals mostly of the numbers you see in every pattern of mathematics. Now let's move on to the geometry, or the number in space. So specific shapes can have a deeper meaning. This aspect relates symbolism, and it is frequently used in architecture. So unlike arithmetic, geometry uses shapes to build up certain equations, and it is most frequently used, kaya nga nasabi dito, in architecture. So bukod sa architecture, pwede rin magamit ng geometry sa engineering, especially when making or shaping up a building. So isa po yun sa mga ginagamit ang geometry po. So the third one is the music, or the number in time. It covers music in general, and particularly the topic of natural harmonics. Yes po, ginagamit rin po ang mathematics in the sa paggawa ng music, especially on measuring the time, measuring the harmony that needs to be used in a certain music. And the last one is astronomy, or the number in time and space. It covers the movement of planets in space and natural harmonies between the planets when looking at the aspect of time. This is the first time that aspects of time and space meet. So understandable that in astronomy, it talks about the heavenly bodies. So dito nga, katulad ng ginawa ng Babylonian, where they actually measure the heavenly bodies, the orbit of the space between spaces. So ganun pa ang ginagawa dito sa astronomy in the quadrivium. And so then we have the 5 major development of mathematics during the medieval period. So ito sila yung mga major development that the mathematicians developed during the medieval, which is a development of algebra. The complete text of Euclid's Element was translated in various versions. So dito naman sa na ito siya, sa pagkakaalala ko is si Al-Khwarizmi, isa si Al-Khwarizmi sa mga nag-translate ng ang book ni Euclid, which is the Elements, into Arabic, from Latin to Arabic. We also have the numerous books on arithmetic and that were published. Also, we have the Indo-Arabic numeral system. So yan po sila yung mga major development of mathematics during the medieval period. And then we have geometry. So geometry is used in the development of some religious designs used during the time, which some are even used until today by infusing mathematics. Their works of art became full of symbolisms and meanings. During medieval times, people used different geometric symbols to defy the religious ideas and beliefs as much as words do. So even religious projects during medieval period, so lahat nai-infuse pa rin or ginagamit pa rin talaga ang mathematics, especially geometry, especially on describing one's art. So let's move on to the calculus. So fun fact, ang tinaguri ang god of calculus was Sir Isaac Newton. So Sir Isaac Newton was a mathematician and a scientist. He was the first person credited with developing calculus. It is an incremental development, as many other mathematicians had part of the idea. Meaning of the incremental development, pinagsama-sama po ang mga idea ng iba't ibang mathematicians, then not just Sir Isaac Newton. So we also have Gottfried, who presentably nag-ambag dun sa pag-develop ng calculus. Usually, developing calculus involves working with incredibly small amounts, meaning pinagtatagpi-tagbig idea yan siya, like any other research po yan siya, or any development po yan, it takes time. So in the past, infinitesimals were the original technique of doing this. These are the things that behave like real numbers, but they can also be thought of as being infinitely small. So calculus is a branch of mathematics that involves the study of rates of change. Before calculus was invented, all math was static, meaning lahat ho may limit. It could only help calculate objects that were perfectly still. But the universe is constantly moving and changing. No objects, from the stars in space to subatomic particles or cells in the body, are always at rest. Meaning po, in no exception, everything changes, especially with time. Indeed, just about everything in the universe is constantly moving. Calculus helped to determine how particles, stars, and matter actually move and change in real time. So with the help of calculus, we were able to determine the different changes in our environment. So calculus, originally called infinitesimal calculus, or the calculus of infinitesimals, is the mathematical study of continuous change. In the same way that geometry is the study of shape and algebra is the study of generalization of arithmetic operations. So calculus was developed in the latter half of the 17th century by two mathematicians. So sa pag tinatagpo-tagpong idea of creating the calculus, so we have the two mathematicians who were able to actually develop the whole concept of calculus, which are Gottfried Leibniz and Isaac Newton. So again, who is the mother of calculus naman? So if a modern math textbook says anything about the Agnesi for whom it is named, it will probably note that Maria Gaetana Agnesi was an 18th century mathematician who became the first woman to write a major calculus textbook. So it's just sa mga major what do you call that, writer sa calculus textbook. So much for that. Now let's move on to the famous mathematicians and their contributions during the medieval period. Now let's start off with Europe's first great medieval mathematician. Europe's first great medieval mathematician was the Italian Pisa, better known by his nickname Fibonacci, although best known for the so-called Fibonacci sequence of numbers. Perhaps his most important contribution to European mathematics was his role in spreading the use of the Hindu-Arabic numeral system throughout Europe early in the 13th century, which soon made the Roman numeral system obsolete and opened the way to advances in European mathematics. So, one of Fibonacci's biggest contribution, aside from the Fibonacci sequence of numbers, was, as stated here, is the use of Hindu-Arabic numeral system throughout Europe. So, isa siya sa mga nagta-translate ng mga Latin to Hindu-Arabic versions of sequences. Also, he also uses the numeral system throughout Europe early in the 13th century. To show off, this is Fibonacci's picture during the medieval era. Now let's move on to the great medieval mathematicians. The German scholar Regiomontanus was perhaps the most capable mathematician of the 15th century, his main contribution to mathematics being in the area of trigonometry. He held trigonometry from astronomy, and it was largely through his efforts that trigonometry came to be considered an independent branch of mathematics. Meaning, isa po ang trigonometry sa pinaka-independent branch of mathematics, isa sa mga aspect that brings mathematics to its pride. His book, De Triangulis, in which he described much of the basic trigonometric knowledge which is now taught in high school and college, was the first great book in trigonometry to appear in print. Meaning, isa po siya sa mga publisher, isa sa mga nag-publish, gumawa ng book in trigonometry. Mention should also be made of Nicholas of Cusa or Nicolaus Cusanus, a 15th century German philosopher, mathematician, and astronomer, whose prescient ideas on the infinite and the infinitesimal directly influenced later mathematicians like Gottfried Leibniz and Georg Cantor. He also held some distinctly non-standard intuitive ideas about the universe and the Earth's position in it, and about the elliptical orbits of the planets and relatively motion, which is foreshadowed the later discoveries of Copernicus and Kepler. So Nicholas of Cusa mostly studied about the heavenly bodies, like the orbit of the planets and relative motion of each planet. Also, siya rin mga discover kay Copernicus and Kepler, one of the renowned stars in our universe. Okay? So, isa rin po si Nicholas of Cusa sa naging impluwensya kay Gottfried and Leibniz, especially in the field of mathematics. And then we have Aryabhata's contribution. So, Aryabhata, a great Indian mathematician and astronomer, was born in 476 CE or Common Era. His name is sometimes wrongly spelled as Aryabhata. His age is known because he mentioned in his book Aryabhata that he was just 23 years old while he was writing this book. According to his book, he was born in Kusmapura or Patipura, present-day Patna, Bihar. Scientists still believe his birthplace to be Kusumapura, as most of his significant works were found there, and claim that he completed all of his studies in the same city. Kusumapura and Ujjain were the two major mathematical centers in the times of Aryabhata. So, ito naman po ang kanyang naging contribution sa ating in the field of mathematics during the medieval period. So, he developed the concept of zero and place value system. He also indeterminate Diophantine equations. He was also one of the developer of the trigonometry, cube roots and square roots, and also he has the Aryabhata's identities and area of triangles. So these are one of the major achievement that brought Aryabhata into fame during the medieval ages. So as a mathematician, he developed these to actually contribute in mathematics, and as now he is renowned as one of the most famous great Indian mathematician during the medieval era. This picture is actually Aryabhata during the medieval ages. So now let's proceed to Al-Khwarizmi and Leonardo Pisano Fibonacci. So Al-Khwarizmi developed the concept of algebra by generating a new method for solving linear and quadratic equation. His revolutionary technique began by putting the equations in one of his 6 standard forms, where B and C were both positive integers. So, isa sa Al-Khwarizmi sa mga naging major developer of algebra during the medieval period. So, with that, he developed a new method for solving linear and quadratic equation that up to this day we use in the field of mathematics. So, Leonardo Pisano Fibonacci. So, Leonardo Pisano Fibonacci was an Italian number theorist. He introduced the word to such wide-ranging mathematical concept as what is now known as the Arabic numbering system or the numeral system, the concept of square roots, number sequencing, and even math word problems. Ayan ang mga naging isa sa mga naging contribution ni Leonardo Fibonacci sa mathematics during the medieval period or the medieval ages era. In here is stated Fibonacci's biography. So, like, noted for he was known for being an Italian mathematician, number theorist. He developed Fibonacci numbers and the Fibonacci sequence, etc. So his mathematical contributions was that he is considered to be one of the most talented mathematicians of the Middle Ages. Few people realized that it was Fibonacci that gave the world the decimal number system or the Hindu-Arabic numbering system, which replaced the Roman numeral systems when he was studying in mathematics. So he used the Hindu-Arabic symbols instead of Roman symbols, which didn't have zeros and lacked place values. In fact, when using the Roman numeral system, an abacus was usually required. There is no doubt that Fibonacci saw the superiority of using Hindu-Arabic system over the Roman numerals kasi hindi niya na kailangan pang gumamit ng abacus to actually solve a problem. So this is the picture of Al-Khwarizmi during the medieval period. So kanina napakita ko na si Pisano. So ito naman po si Al-Khwarizmi, which is an Islamic mathematician. So lastly, we have René Descartes and Pierre de Fermat. So René Descartes contributed significantly to the development of modern physics. Most importantly, he provided the first distinctly modern formulation of laws of nature. So isa siya sa mga naging first developer or contributor for the formulation of laws of nature, sabi nga dito. So also we have Pierre de Fermat, a French lawyer and amateur mathematician. Fermat helped develop infinitesimal calculus, best known for his Fermat's last theorem, which he described in the margin of a copy of Diophantus Arithmetica. So isa rin sa mga naging nilalaman ng Diophantus book of arithmetic ay ang contribution ni Fermat, or yung naging naging contribution ni Fermat sa mathematics, which is Fermat's last theorem. So isa rin si Fermat sa nagtulong na kaila Isaac Newton and Gottfried Leibniz in the field of calculus, kung saan siya isa sa mga naging developer of the infinitesimal calculus. So here we have the picture of René Descartes and Pierre de Fermat. That's it. Thank you everyone for listening to my discussion about mathematics in the medieval period. Again, I am Monique Matthew Alcuevas, and this is History of Mathematics.